Section 7.7, Inverse Relations and Functions. In this particular section, we're going to look at actually finding the inverse of both relations and functions. Now, if you think back from about chapter 1, chapter 2, somewhere in there, we talked about relations and functions. And a relation is any set of values where there's a domain and a range. A lot of times this will be given to you as ordered pairs. They don't necessarily fit the characteristics of a function. A function is a specific type of relation where each element of the domain is paired with only one specific element in the range. Okay, these can be either done by ordered pairs or they can be made by different equations. Like you'll remember a linear function is a function. Every time you put in something for the domain, you get specifically one thing for the range. Same thing for a quadratic function and so on. Those equations specifically generate for every number for the domain a specific number in the range. Okay, so finding the inverse of a relation is very simple. The inverse is where we want to take and switch what our independent and our dependent, or our domain and our range values are. So what was the domain is now going to become the range, and what was the range or the y values now become the domain or the x values. So when you get a list of ordered pairs, like in the case of a relation, it's very simple to switch the ordered pairs. Like for example, this ordered pair would normally be 1, -1. But if I want to do the inverse, I switch the order of those ordered pairs, and the inverse is now the ordered pair -1, 1. Now for graphing purposes, the -1 now becomes the x, and the y the x becomes the y. So we are actually switching them, okay? So if we were going to put these on a graph, we would graph them just like the ordered pair says. Okay, 1, 3, and then we would have 1, 4. So with a list of ordered pairs, it's really simple to do the inverse of that relation. You just simply switch the places of the x and the y. The y's become the x's and the x's become the y's. Okay, you can do that with this example over here really quickly. The ordered pairs for the inverse would be 2, -2, 0, -1, 1, -1, and 3, -2. And again, in the earlier chapters, we talked about how to tell whether or not these are functions. And sometimes you do, the original part might be a function, but when you do the inverse, it's not, or vice versa. The original might not be a function, but when you do the inverse, it is. And that's still true as far as what makes a function and what doesn't, like we did earlier in the year. Okay, so if we need to find the inverse of an actual equation, a function that's in equation form, it gets a little bit more challenging. You actually have to physically switch the variables x and y, and then you're going to solve your equation to get y by itself, like we normally put it in that format, in a standard form. And so here we're going to do this example. We're going to find the inverse of y equals x squared plus 3. So the first thing it says I need to do is interchange my variables, which means I need to actually take the y and make it an x, and the x and make it a y. So this function over here is now going to become x equals y squared plus 3. Okay, and then from there, you have to use all of your prior knowledge about solving an equation. I'm trying to solve for y, which means all this stuff that I'm doing to y needs to get moved over here with my x so that y will be all by itself. So when I look at this, the first thing I see that I need to do is to subtract 3. Okay, which on the left-hand side of my equation is going to give me x minus 3. And over here is going to give me y squared. Okay, so then the second thing would be to get rid of our exponent of squared. And we can do that by square rooting both sides. Now remember, we did this back in an earlier chapter. Anytime you solve an equation by square rooting both sides of the equation, you have to remember to include the possibility of both a positive and a negative version of what you are square rooting. So we're going to say our function is plus or minus the square root of x minus 3. Now, some of you may not be comfortable with this, and we're typically used to seeing the form where the y is on the left side. So if you just want to simply switch that around and put your y over on the left, you can. But the inverse of my function is the equation y equals plus or minus the square root of x minus 3. Okay, so every problem is going to be a little different. It depends on the equation you start with. You're going to have to do some rearranging of terms, but you simply start by switching all the x's and making them y's, all the y's and making them x's. Okay, so let's do one with function notation. And we're going to do the inverse of the function f of x equals the square root of x plus 1. Okay, so since we need to interchange the variables x and y, the first thing that I'm going to do is I'm actually going to remove my function notation, and I'm going to rewrite this and put my y equals back in there, just so that I can simply switch my x and my y a little bit easier. Okay, so now the next thing, actually switch the x and the y. So this becomes x equals the square root of y plus 1. And now we start the solving process. So we got to figure out how do we get all this stuff and get to y here. Well, in this case, the first thing that I see that I'm going to need to deal with is this square root sign. And the way that I do that is I'm actually going to be squaring both sides. Okay, so I square both sides and I end up with x squared equals, on the right hand side the square will cancel out with the square root, and I'll just end up with y plus 1. Okay, once I get y plus 1, I subtract 1, so I end up with x squared minus 1 equals y. Again, if you like, put your y on the left hand side, y equals x squared minus 1. Now, since my original problem started with a function notation up here and they wanted me to find f inverse, which is what this says right here, I'm just simply going to rewrite that. F inverse of x equals x squared minus 1. Okay, that just keeps consistent with what my original problem was asking me to do.